Right. Welcome again to Wickerson Studios. This is just a second part. I'm asking the question, why shift to parametric modeling in Grasshopper for Rhino3D? And I've gone through a little bit of fabrication of points and why it's convenient to think parametrically and computationally in Grasshopper to generate those in Rhino. And we'll go on to curves. And of course, we could go in here. We could just create polylines the way people usually do in Rhino static. We can also go in there and produce them from points and curves. We could do them points affected by those curves, or we could right click, I believe here, and have them go through the points. Of course, we have to have the points already selected, so let's right click, boom, 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 and then we'll do the right click here, and there you go, you're stuck in selecting the points that you want to iterate through in a certain order. How to exactly do, please enter, I entered only one, which isn't going to really do well. Let's select points to go through, there they are. Hit enter, and there's your curve that dances through those in a certain order. Now, that's one way to make a line. Totally fine. You can change the degree, the knots, and make them interpolated or anything like that. Well, I basically want to go in here and say, well, let's generate curve in a different way. Let's generate it in Grasshopper, three-dimensional, maybe a NURBS curve, or maybe a interpolated curve. And then you can get in here and have fun with the enumerated points of whether it's a degree or there's periodic, what is the knot style. There's a whole bunch of wonderful node attributes as you get into node scripting. But how would I build this? How would I go about making something like that? So let's just zoom out. Let's make that script. Not too unlike what we did before. We generated a point system. So we went into generating a point. We actually I chose to use ranges out of the sets function instead of just finding attributes. Let's say that number 10 was the one I was using for the domain. I think I'll extend, well, maybe I'll just keep it the same. I showed you an example of double clipping, hit a digit between 0 and 0 point something and dot 10. Actually, we can just type in 2.00 and that will come up with the number slider 0 to 10 with 2 decimal places. We can put those in as the point attributes stand up with that point, but you'll see what I did above. Very simply brought in the range component out of the sequence and pop that range in there, which we're going to use quite a bit here. The domain's going to default to there, and I'm going to want a slider from 2 to 10, integer value up in the steps, and I'm going to pop that into the x direction. And this one, I'm actually going to pop it into the x, and I'm going to be using another one for the z to produce these points. I'm going to produce the same model that I had above. I am not going to bring in a z component with a control shift. I can take that out. And there we go. And with a little bit of a graph tool, which I did above, you now have your grid. And then once again, I put in a move tool for my transformations. This is just fairly repetitive to what I did in the last one. I'm going to move, these geometries in a motion of z. And I'm going to put those through the range of z. And with another graph on here, I should be fine to produce a grid of points. And then I went in and I thought, well, let's just get into a list item. And let's get into a list length. Let's flatten the list length so we end up getting a single digit out of it, or count out of it. Put that in as the index, but before we do the index, we will go into the sequence random. We'll put that through a random number slider to grab any one out of this list, and I will seed it differently, which I will end up using. Here it is. And that's what I was going to do to produce a series of lines and points, and you'll see exactly as I continue. I'm going to choose number of points 2 to 10. Same thing. Of course, that's going to affect the parametrically the number slider. There are the points that are being selected. Pretty interestingly enough, what have I done? I have not flattened the list here, so it's reading as that, and I should be able to pull those 10 points and have a seeded tool to pick those. And then what I did was I just chose as a container those points and put them directly into the line nodes that are available to me under lines. And you'll see that there's a bunch up here. If I move my head, I've got the polyline, I've got the NURBS interpolated, and I have the NURBS curve. There's a bunch of other stuff you can experiment. And I just want you to pop those in and make sure they're all working. And there you go. You've got a wonderful little lines that if I remove the other ones, I've got my polyline selected, which is random and parametric. Can be any one I want. What a nice way to generate controlled, logical, computational lines. I've got my interpolated curves. And I've got my NURBS curves, and you're like, well, that's just a chaotic little mess, so why would you end up doing all that? Well, I said, okay, I'll agree with you, it's a chaotic little mess. Why would I end up doing all that? Since I did it above, I'm not going to do it below again, so I'll just erase it. But with that, I thought, let's get a little bit of control. So let's go back into it again. And let's generate what I call the Daniel Kristev style, because I've learned so much from him. It's been very exciting. Let's produce a point. And with that point, let's take it through a couple of ranges. So with those digits, I'm going to, because you have the number sliders now on your screen, you're using the GitHub files, I'm just going to copy that 10. I'm going to copy that steps for finesse, because I'm going to get into some trigonometry and I want lots of points. And I'm actually going to copy a couple of amplifying sliders from 0 to 10 with a lot of decimal places. And you're going to see how these numbers actually play a role. And one thing that's good to do is you could go in here and you could do the step, you could do the domain. You can call that the domain, and that will change over on the number sliders, because bifocals don't actually work with number sliders. And I don't think they work with panels either. You end up naming the parameters coming in under number sliders. And of course, once again, my favorite tool, one of my favorite tools besides Gene Pool, is to grab that range, and we're going to use that as a domain. We're going to use that twice more. And we will use our step count for finesse, because we're dealing with very small numbers, and we're going to want to control that sine curve to make some beautiful objects. This is going to make a little sense in a second. And then we're going to do the magic of, if you have small numbers, it'll work in the math tab. Green for sine, and we're getting very close to using the expression node, and we'll go there, and cosine. And if I start to run those in, you're going to enter it's going to be an interesting little point that I just produced a very beautiful circle. Now it's a little crazy to interpolate those points. You'll see why in a minute, but I can start to extend those up, and they're in a nice order of a helix. I've ended up making a helix. The only thing I'm going to do for some amplification is I'm going to use those multiplication tabs, just like I'm writing an equation in mathematics, whether you're used to it or not. I'm going to have one slider that's going to affect the x direction under sine, and I'm going to have the other one be amplified under y. I'm going to plug those in, and it'll override the other ones. Of course, I wouldn't want those digits in here. So now you'll see I have some pretty good parametric control over top of that curve by the points. And I also can provide a lot more points or a lot less points, and then I can also extend it to its full length or not, and take it through as many rotations as I want to through that. What I may end up doing in here, just to allow things to be kind of beautiful, is use the ability of mathematics to jump into something as beautiful as pi. I'm going to filter through all of this, and I'm going to put this as a count, and there's a control shift I haven't used yet. Grab all the inputs and put them in here. I'm going to have a control count of I'm counting pi's, and another little trick I'm going to show you in here is edit snapping. I'm going to have 0, and then I'm going to have 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, and I'm not going to bother with the rest, but that's going to make me have some snapping beautifulness to these points. As I take it, you'll see, and you have to highlight on there, and you want to slide in your number slider so you get some control. You see that it snaps to some very nice positions of pi, halfway and all the way up. So those are just some nice ones to have some control of where you want it to rotate through. Say you want to have some architectural or engineering control on what pi is doing. So I would say have a dip into that and see what's going on mathematically, slow down and do it, and then visualize your information as well. I'm going to take this one over to group. We're going to take everything else off here, and what I'm going to do is the same thing I did the last one, is just put in a container of points, which is not necessary, but I like it, and then I'm going to grab those 3 forms that I had before. Now if I only wanted to select them, I go left to right and anything inside the box. That way I bypass the group, and you'll learn a lot of tricks and things with me as you learn this style. But another reason to go parametric, there it is, we're done. We'll take off all of these and go to preview off. We will group this entire system, and there it is. We will take that to group, and we'll slide it down here, and then for this one I'll probably just take that one to disable, and then I can play around and do whatever I want to add to these curves as I go. I've got my very nice interpolated curve that can be appreciated. I've got my NURBS curve, which is very close to it, so that was my NURBS curve. That's my interpolated curve, and there's my polyline. And if you want to really see the difference between what's happening in a polyline and another one, all you have to do is bring this count down to where it was before, and you can see why that had such an effect on it. Of course, it ends up looking like a NURBS curve or a interpolated curve if you take that count up real high. And then you can also fudge that out to the sides in the x direction, and you can pull that in the y direction. Now you've got a pretty nice geometry, and I would say your 3 curves you're working with here, which produce this very nice little form as it steps up, is a lot more interesting than this chaos which is happening here, but certainly what was happening here within the Rhino window of having to go in, make these points, grab that curve, put my points on, and start to push and pull those points. Another showing of why the shift parametric modeling in Grasshopper for Rhino is so powerful and why you would go that way. The magic that's really happening behind the scenes that you might be starting to appreciate is we're starting to get into the sense of writing expressions in nodes, and as we get into math, we're going to dip into these functions, and then what's next but some beautiful Python and C# nodes. So it's bound to happen if you're going to go parametric into computational arts into scripting, and you're going to understand this even better and better and better. And the projects you want to make, you're going to become second nature to the syntax of writing it, and you're going to have incredible abilities to dip into what I think are the main four or powerful things the future is full of, which is robotics, AI, machine learning, and data science. And that might be a big stretch for you, but I've been playing with this 3 years, and that's where I've been pushed into going and playing with different libraries. Anyhow, making curves, I'll take it off here. We'll save that as number 2 script, and that will be available on GitHub, and we'll save the next ones. And what's next on our list? Look at that, circles. So we'll basically go in here and save it as a file of 003 circles and see what we can end up making with it. Once again, that's not important. This stuff is actually producing, it's actually producing some pretty interesting geometries for us as we go through to think what's actually happening in here. So you got your curves, and you can start selecting in blue what you want to play with and see what's actually going on here. A lot of data, a lot of information. It's kind of like, if you want to think about it, and I'm just going to throw this in here, what you've been producing in your scripts here. You have been writing a beautiful script in Rhino since you began today, and as we played through a little bit. But instead of having it here in the Rhino window written into the command lines of what's recorded, you've actually have the scripts written right out here for you in GH files that you can come back to and use as snippets and open them up and cluster them and write them in the nodes and all these wonderful things. A lot of information, but I'm pushing this. I'm just going to keep plugging through points, lines, polylines, curves, circles. We're going to run down here until we learn Rhino because of how we learned how to script it in node scripting in Grasshopper. Thanks very much for watching.